Today I'm talking about Gauss's law. The Gauss's law is the electric flux passing through any imaginary closed surface is equal to the total charge enclosed by that surface. This surface is called Gauss's surface. Gauss's surface. And this surface and closed surface is the same surface. This is also Gauss's surface. And firstly, we have to choose Gauss's surface. The candidate for Gauss's surface is rectangular parallelepiped. Rectangular parallelepiped has 6 Gauss's surface, and this enclosed rectangular parallelepiped has 6 Gauss's surface: top surface, down surface, right surface, left surface, front surface, and back surface. For example, we have source charge Q inside the rectangular parallelepiped. This source charge creates electric flux. For example, this electric flux, and this electric flux, and this electric flux, and this electric flux, and this electric flux. The total electric flux passing through this 6 Gaussian surface is 5. The 2 electric flux are passing through the top Gaussian surface, and 1 electric flux is passing through left Gaussian surface, and 1 electric flux is passing through right Gaussian surface, and 1 electric flux is passing through bottom Gaussian surface, and this total electric field, electric flux passing through Gaussian surface is 5. This is equal to the total charge inside the volume enclosed by Gaussian surface. This is 5 coulomb. This is called Gauss's law. This law and the electric flux which are passing through Gaussian surface is equal to the total charge inside the volume enclosed by Gaussian surface. And sphere can be also Gaussian surface. And source charge Q is located inside the sphere, and this source charge creates the electric flux like this flux, and this flux, and this flux. At this case, the 4 electric flux are passing through Gaussian surface, and the electric flux which passing through Gaussian surface in 4, this is total charge inside the sphere. This is the 4 coulomb. This is Gauss's law. And some example, we think about cylinder. The cylinder consists of surface, the top surface and bottom surface, and side surface. And 3 Gaussian surface consists of the cylinder. The source charge Q inside the cylinder. This source charge creates electric flux like this flux, and this flux, this flux, and this flux. Though we have total 5 electric flux, 2 electric flux are passing through the top Gaussian surface, and 1 electric flux is passing through the bottom Gaussian surface, and 2 electric flux are passing through side Gaussian surface. And total electric flux is 5. According to Gaussian law, this is total charge inside the cylinder. This is 5 coulomb. This is Gauss's law. In summarizing, the total charge quantity inside the volume enclosed by Gaussian surface is equal to the electric flux which are passing through Gaussian surface. This is the total charge inside the volume enclosed by Gaussian surface is electric flux density multiply the area, or volume charge density multiply the volume. This is Gauss's law. We take some examples. The first example is electric flux density and 0.3 R square AR nanocoulomb per meter square in free space. Free space has permittivity epsilon 0. Epsilon 0 is 8.854 multiply 10 to the power of minus 12 farad per meter. The first question is find the electric field at point P. We have already known the relation between electric flux density and electric field in free space. The electric flux density is permittivity multiply electric field in free space. So electric field is 1 over epsilon 0 multiply electric flux density. So this is 1 over 8.854 multiply 10 to the power of minus 12 multiply 0.3, R is 2, so 2 square AR. This is 10 to the power of minus 9, and this is nano is 10 to the power of minus 9. So unit is coulomb per meter square. Coulomb per meter square. This electric field, the volt per meter. The unit is volt per meter. And the answer is 136, approximated 136 AR. Unit is volt per meter. This is the answer of this question. And second question is find total charge within R equals 3. We express the electric flux density by R. So this is spherical coordinate. We think about sphere and with R equals 3. This sphere and R equals 3. And the surface of sphere with the surface with R equals 3, and this is surface. This is surface. Oh, this is this surface. And the differential surface is R d theta multiply R square sine theta d phi. This is a differential area. And total charge is electric flux density dot ds vector. The x vector has the direction. The direction of the differential area is the outward of the surface. So this is the r direction. So the x vector is r squared sine theta d theta d phi ar vector. So total charge q is this integration is for the integration for area. So this is double integral, and d vector is 0.3 r squared ar vector dot ds vector is r squared sine theta d theta d pi ar vector. Ar vector dot ar vector is 1, and the range of theta for the surface of full sphere is from 0.pi, and the range of pi is 0.2 pi, and r equals 3. So this is 0.3 multiply the r square multiply I square is r to the power of 4. That is 3 to the power of 4, and integral from 0 to 2 pi d pi multiply from 0 to pi sine theta d theta. This is 0.3 multiply 4 to the power 3 to the power of 4 multiply 2 pi multiply minus cosine theta from 0 to phi. This is 1. So this calculated this is 305.336. The unit is nano coulomb. This is the answer of this question. And next question is total electric flux passing through the Gaussian surface of sphere. This is total charge inside the sphere. So sphere is r equal 4. This question is the same as this above question, except for r equal 4. So this is I employ this 0.3 multiply 4 to the power of 4. This is different. This is 3 over power of 4. This is 4 to the power of 4. And multiply 2 pi. 2 pi. And yeah, this is 2 pi. So this is, as we have, this is the answer. This is the answer, the nanocoulomb. Right? So this is the total charge quantity inside the sphere. It is equal to the electric flux which are passing through the Gaussian surface of the sphere. I had some mistake. This is sorry, this is not 1, this is 2. Right? So 0.3 multiply 3 to the power of 4 multiply 2 pi multiply 2. And this also multiply 2 nanocoulomb. This is the answer. This is the real answer of the question. The next question is find total electric flux leaving xyz equal plus minus 5. It means the Gaussian surface is 6th surface of rectangular parallelepiped. So Gaussian surface is 6th surface parallelepiped. The surface of parallelepiped is Gaussian surface. We have 6 Gaussian surfaces: top surface, bottom surface, right surface, left surface, front surface, and back surface. And this is x direction. This is the y direction. This is z direction. And this is this is x equal minus 5, x equal 5, y equal minus 5, y equal 5, z equal minus 5, z equal 5. And we find electric flux. The electric flux which are passing through Gaussian surface is equal to the total charge inside the volume enclosed by Gaussian surface. So we, instead of finding this, and we try to find total charge by Gaussian law. The total charge is 0.1 microcoulomb is at 1 point minus 2.3. This is origin, and x, y, and z. And 1 comma minus 2 comma and 3 in this. This is still, this source charge is still inside the volume enclosed by Gaussian surface, and 0.1 minus microcoulomb. And this is at minus 1 comma 2 comma minus 1 comma 2 comma minus 2. And this is 1 over 7 microcoulomb. It's located inside the volume enclosed by Gaussian surface. So this is total electric flux is total charge quantity inside the volume enclosed by Gaussian surface, and 0.1 plus 1 over 7 microcoulomb. This is the answer of this question. And second question is given line charge density pi microcoulomb per meter at minus 2,3. The Gaussian surface is 6 surfaces of the rectangular parallelepiped, and the Gaussian surface and this. And this is x, this is y, and this is z. 0. And this is x equal minus 5. This is x equal 5. And y equal minus 5. Y equal 5. Z equal minus 5. Z equal 5. And line charge is located at the center is minus 2,3, and minus, this is origin, and x direction, and y direction, and z direction, and minus 2,3, and this is center of line charge. Line charge is this is line charge. Line charge is from z equal minus 5 to z equal 5. And the electric flux, which are passing through Gaussian surface, is total charge inside the parallel pipe. This is 10, and 10 multiply line charge density microcoulomb is the answer of this question. Right? The total charge inside the rectangular parallel pipe is the length multiply line charge density, so 10 pi microcoulomb is the answer. The next question is uniform surface charge 0.1 on y equals 3x. The Gaussian surface is the sixth surface of rectangular parallel pipe. This is rectangular parallel pipe. So this is x direction, y direction, and z direction. And this is origin. And this is x equal minus 5. This is x equal 5. Y equal minus 5. Y equal 5. And z equal minus 5. Z equal 5. And y equals 3x is this line. This line. And when x equal 1, y equal, when x equal 1, y equals 3, and y equal 5, x equal 3 over 5, and z equal minus 5 to 5, and this is, the plane is this plane. So y equals 3x, this is y equals 3x. That this plane, the charge is located on this plane, and we have already known surface charge density is 0.1 microcoulomb per meter square. So electric flux, which are passing through Gaussian surface, is the total charge quantity inside the rectangular parallel pipe. So this is rho s multiply area. Area is this area. So we have already known rho s, and the area is 10. 10 is from 0 equal minus 5 to 0 equal 5, and this length. We try to find this length. This length is, this is x and y. This is a 0. No, this is a the y and x, 5 and 5 over 3, and the range of y is from minus 5 to 5. This is minus 5. And this length is L. This L is 2 multiply this length. So we can find that this length is square root 5 square plus 5 over 3 square. So psi is the electric flux which are passing through Gaussian surface is the total charge inside parallel pipes. We try to find the total charge inside the parallel pipe is rho s 0.1 multiply s is 10 multiply this length 2 multiply square root 5 square plus 5 over 3 square. So the answer is 10.54 microcoulomb. This is the answer of this question. So today we discussed about Gauss's law. The Gauss's law is the electric flux which are passing through Gaussian surface is equal to the total charge inside the volume enclosed by Gaussian surface. Thanks for listening this video, and see you later. Bye bye.